This is Section 9, Mean, Median, and Mode, the lecture for Making Sense of Statistics, a conceptual overview. In Section 8, we briefly talked about the mean. We acknowledged that the mean is the most frequently used average. And we also talked about the mean being the balance point in a distribution of scores. Specifically, it is the point around which all the deviations sum to 0. So also for a review, we need to recall that the mean is sensitive to extreme scores. Now the median is an alternative average. So the value of the median in a distribution of scores has 50% of the scores above the median and 50% of the scores below the median. So it is defined as the middle point in a distribution. Now, unlike the mean, the median is insensitive to extreme scores. So it is an appropriate average for describing typical participants in a highly skewed distribution. That is unlike the mean. Now, to determine the median, let's look at this particular example. So it is the middle point in a distribution. Now, what we've done is we have 11 scores and we have lined them out from in order. So we have from low to high. So we have the lowest one is 61, the highest one is 92. Now, if there are 11 scores, and the middle score has 50% on each side, that gives us the median of 81. So 81 is the value of the median for this set of scores. And you can see that it is in the middle, that there are 5 scores above 81 and 5 scores below 81. Now this works quite well when there are an odd number of scores. You would simply pick the middle score. That makes sense, right? Now let's talk about determining the median when we have an even number of scores. Now we again have put our scores in order from low to high, and there are 6 scores. So which one is the middle score? Well, what we do is we take the sum of the 2 scores closest to the middle, which would be 7 and 10. We would add them, which is 17, and then we would divide it by 2. So that would give us 8.5. So the 8.5 is the value of the median of the set of scores. Now remember, the median is insensitive to scores. Now here again, let's look at these 6 scores. We have 6 scores. We have again a middle score. We take the sum of the 2 scores, 7 plus 10. 17 and divide by 2. So 17 divided by 2 is still 8.5. Now remember, again, you see that in this slide, the range, the order of these scores from low to high is from 3 to 229. And 229 would affect the mean. However, it does not affect the median of the distribution. So let's look at the mode. Now the mode is another average, and it is actually defined as the most frequently occurring score. So let's look at an example. Now this is also easy. I'm sure that most of you learned this in 4th, 5th, or 6th grade, but we are going to review it. Now, so here we have the mode. So we have all of these scores, again, arranged in order from low to high, so from 2 to 12, and see that the most frequently occurring score is a 7. So we say 7 is the mode for the scores. Now, one disadvantage of using the mode is that there may be more than one mode in the distribution, and as you see, we again have arranged our scores from low to high, and we have 2 modes. We have the mode of 20 and a mode of 23. Now, that means that there are 2 modes in this set of scores and distribution. Now, how do we choose which average to use? Well, the mean is usually the most appropriate. However, it is not appropriate for nominal or ordinal data. The mean can only be used with interval or ratio levels of measurement, and it is almost always inappropriate for use with highly skewed distributions. How do you choose which average to use? Well, let's look at the median. Well, you choose the median when the mean is not appropriate. And you do not use the median for nominal data. The mode, however, is the only appropriate average for nominal data. It is chosen when an average is needed to describe nominal data. Now, when describing nominal data, it is often not necessary to use an average because percentages can be used for an alternative. We've already discussed this, where if there are more registered Democrats than Republicans in a community, the best way to describe this is to report the percentage of people registered in each party. Now, where are the positions of the averages in skewed distributions? Well, let's look at it from a positive skewed distribution. As you see, our mode is our apex. It is at the topmost point of the curve. And if you look at the positive skew, you see that the median is to the right of the mode, and the mean is actually further right. Now, this clearly makes a impact if you look at that the mean has the highest value because it is pulled in the direction of the extremely high scores. Now, if you look at the negative skew, you see the mode also is the highest point, the apex. The median is just to the left of the mode with 50% of the scores on either side. And again, in a skewed distribution, you see that the mean is pulled in the direction of the extremely low scores. And so, as noted earlier, the mean should not be used when a distribution is highly skewed. So now you see that in a positive skew, the mean is actually higher than the median, and when there is a negative skew, the median is higher than the mean.